The next set of example is iron metal does not react with water under ordinary conditions. The reaction occurs only when steam is passed over red hot iron and the products are iron 2,3 oxide and hydrogen. So, iron does not react with water easily, it reacts with steam. Moreover, the iron also should be red hot. The equation for reaction of iron with water is iron reacts with water taken in the form of steam to form iron 2,3 oxide and hydrogen gas. Metals like copper, silver, gold, platinum do not react with water even under strong conditions. So these metals do not react with water. So we can say that different metals react with water under different conditions, and the order of reactivities of different metals with water is: sodium reacts more vigorously as compared to magnesium, then zinc, then iron, and then metals like copper and silver. So this is the order of reactivity with water, which decreases from sodium to copper. Moving on to the next chemical property of metals, reaction with acids, and that too we are considering dilute acids. Many metals react with dilute acids and liberate hydrogen gas. Only less reactive metals such as copper, silver, gold, etc. do not liberate hydrogen gas from dilute acids. So considering the reactivity of different metals with acids like hydrochloric acid and sulfuric acid, we can see different examples for the reaction of metals with dilute acid. For example, sodium reacts with hydrochloric acid to form sodium chloride along with hydrogen gas. Sodium can also react with sulfuric acid to form sodium sulfate along with hydrogen gas. Similarly, magnesium reacts with dilute hydrochloric acid to form magnesium chloride and hydrogen gas. Magnesium can also react with sulfuric acid to form magnesium sulfate and hydrogen gas. Metals like zinc react with dilute hydrochloric acid to form zinc chloride and hydrogen gas. Similarly, aluminium forms aluminium chloride with dilute hydrochloric acid, and it forms aluminium sulfate with dilute sulfuric acid. Metals like iron react very slowly with dilute HCl or dilute H2SO4, and therefore it is less reactive than the other metals like zinc and aluminium. We can consider the example of iron reacting with dilute hydrochloric acid to form ferrous chloride, and hydrogen gas. Iron also reacts with dilute sulfuric acid to form ferrous sulfate and hydrogen gas. Metals like copper, silver, gold, and platinum do not react with dilute hydrochloric acid or dilute sulfuric acid. So these metals like copper, silver, gold, and platinum do not react with dilute acids. So we can say that not all the metals react with dilute hydrochloric acids, and also the different metals which react with dilute hydrochloric acid and dilute sulfuric acid react at different speeds. Metals when react with these dilute acids, they form their corresponding salts along with hydrogen gas. So considering the reactivity of different metals with dilute acids, we can say metals like sodium react very easily with dilute acids as compared to magnesium, then aluminium, then zinc, then iron, and then metals like copper. So this is the order of reactivity of different metals with dilute acid, which decreases from sodium to copper. Moving on to the next chemical property of metals, that is reaction of metals with salt solutions. When a more reactive metal is placed in a salt solution of less reactive metal, then the more reactive metal displaces the less reactive metal from its salt solution. So, when a more reactive metal reacts with a salt solution of a less reactive metal, it displaces the less reactive metal from its salt solution. For example, we take a solution of copper sulfate, which is blue in color, and we put a strip of zinc metal in it. We can observe that the blue color of copper sulfate fades gradually and copper metal is deposited on the zinc strip. This means that the reaction that occurs is zinc, we've taken a solid strip of zinc, we've put the strip in blue color solution of copper sulfate, zinc displaces copper and forms zinc sulfate, while copper metal gets deposited on the zinc strip. Here zinc displaces copper from its salt solution, and we can say that zinc is more reactive than copper. However, we take a zinc sulfate solution and put a strip of copper metal in this solution, no reaction occurs. So we've taken zinc sulfate solution and we put a strip of copper in it. We see that there is no reaction. So copper does not displace zinc from its salt solution. This means that zinc is more reactive than copper, and copper, is being less reactive than zinc, cannot displace zinc from its salt solution. However, if we put gold or platinum strip in copper sulfate solution, then copper is not displaced by gold or platinum, thus gold and platinum are less reactive than copper.